Hello everyone, in this video we're going to explore topic 10.12 Lagrange Error Bound. Alright, we're going to talk about the remainder of a Taylor polynomial. Alright, so in the topic 10.11 we learned that the exact value of the function f(s) equals the polynomial approximation plus the error, right? Now the error, sometimes we call this one as the remainder. So then I'm going to subtract Pn of s both sides. I'm going to get this one right here. So the absolute value of the error equals the difference between the exact value and the approximation, right? And then we're going to use this inequality right here to find the range of f(s). Now we're going to talk about the Taylor formula and Lagrange error bound. Right, if a function f is differentiable through order n plus 1 in an interval I containing value of c, then for each s in the interval I, there exists a number z between s and c such that f(s) equals the polynomial approximation plus the remainder, right? So remainder right here is the term after this guy, right? So which means it's going to be the n plus 1 derivative of s, right? Now in this situation, it should be the value of z, where z between s and c. So how do you understand z? We're going to take a look at the example later, right? Over this is n, the next term should be n plus 1 factorial, right? This is power of n, this one should be n plus 1, right? Now, the Taylor's inequality. We're gonna represent the error as a bound using the inequality, right? So it's gonna be exactly the same thing as this guy right here. We just replace the equal sign with the less than inequality right here. The notation mass of n plus 1 derivative of f of c represent the largest value of n derivative of f of c will take on for a value of c that will typically lie between c and s. Now, example number 1, the third Lagrange polynomial for sine s is given by p sub 3 of s equal s minus s cubed over 3 factorial. Use Taylor's theorem to approximate sine of 0.1 by p sub 3 of 0.1 and determine the accuracy of the approximation. Alright, so this is a Lagrange polynomial, which means the center equals 0, right? Alright, so we have sine of 0.1 is the same thing as p sub 3 of 0.1, right? Because we're going to use this one to approximate this guy, right? So it's going to be substitute 0.1 for s, right? So I have 0.1 minus 0.1 power of 3 divided by 3 factorial, right? So we're going to print up the calculator. 0.1 minus 0.1 to the third divided by 3 factorial, right? So you divide by 3 and you hit the quotient right here and hit the factorial and press Control Enter. It's going to be 0.099833, right? We're going to use the formula absolute value of the r sub 3 of s, right? Formula right here. Alright, so this is n, this guy must be n plus 1, this guy must be n plus 1, and this guy must be n plus 1, right? So keep that in mind. So this is r sub 3 of s. It's to be less than or equal to absolute value of maximum, which means the largest value of f, the fourth derivative of z, right? This guy is 3, this guy must be 4, right? Over 4 factorial, right? Times s minus c to the 4, right? Now c equals 0 and s equals 0.1, right? So I'm going to replace this one with 0.1 minus 0, right? Alright, and then I'm going to simplify this guy, so it could be absolute value of. Now you know that the function f of s equals sine s, right? Now f to the 4, if you take derivative, it's gonna be around sine and cosine, that's it, right? F prime of s is gonna be cosine s, and then f double prime of s is gonna be negative sine s, right? And f triple prime of s is gonna be negative cosine s, and the fourth derivative of s is gonna be sine s again, right? And you know that absolute value of sine s always less than equal to 1. Absolute value of cosine s always less than equal to 1. So keep that in mind, right? So the maximum value of this one, it doesn't matter what the value of z is, right? Remember z between c and s, right? C right here equals 0 and s right here equals 0.1, right? So this guy doesn't matter at all. The sine cosine function maximum values always 1, right? So I have 1 over 4 factorial, which means 24, right? Times 0.1 power 4, right? It's gonna be 0.00004, right? Determine the accuracies of the approximation. So the error is absolute value of the actual value, which means sine of 0.1. Subtract the approximation, it's going to be P3 of 0.1, right? So it's going to be absolute value of sine of 0.1 subtract this guy right here, right? So it's going to be 0.1 minus 0.1 cubed over 3 factorial, right? I'm going to print up the calculator. It's going to give me this value, right? And the error right here is going to be 4.16 times 10 to the negative 6, right? And this guy always less than or 3 of s, right? Which is the value right here. Now let's move on to question B. The 4-degree Lagrange polynomial for cosine s is given by this guy. If this polynomial is used to approximate cosine of 0.2, what is Lagrange error bound? Alright, so the key information right here, Lagrange polynomial, right? Which means the center c equals 0. Alright, keep that in mind. Now the s value right here is 0.2, right? This one is P sub 4, right? So we have R sub 4 of S always less than or equal to absolute value of maximum of the fifth derivative of Z times S minus C power of 5 over 5 factorial, right? Now we're going to substitute values. It could be absolute value of maximum of the fifth derivative of Z times S right here equals 0.2. Subtract C is going to be 0 power 5 over 5 factorial, right? Now the maximum right here equals 1, right? So we have absolute value of 0.2 to the fifth over 120, right? We're going to print up the calculator. 0.2 to the fifth divided by 120. And then press Ctrl Enter. It's gonna give you 2.666 repeating, right? Times 10 to the negative 6, right? Now let's move on to question C. If the Taylor polynomial about s equals 0, so this is the center, right? Whenever we see about, this is center, so c equals 0, right? Which means this guy becomes the Lagrange series, right? Lagrange polynomial, right? For the approximation of e to the s is given by this guy. What is the upper bound for the error in the approximation of e, right? So we need to find it's going to be less than or equal to absolute value of maximum. Now the function f(s) is e to the s right here, right? So if you take the sixth derivative, it's still e to the s, right? And you know that the value of z is between c and s, right? C equals 0 less than z and s equals right here e only, which means e power 1, right? So when you match this guy and this guy, s equals 1, right? So if you exponentiate 3 sign, it's going to be e power 0, e power c, and e power 1, right? And the maximum right here, e power 1, right? So you have absolute value of e times s minus c, which means 1 minus 0 is going to be 1 power 6, right? Over 6 factorial, right? And then you're going to print up the calculator. 1 power of 6 is going to be 1, right? So you have e only raised to the first. Then you divide by 6 and you press the button right here. Pick the factorial, press Ctrl, Enter. The answer is 0.003775, right? Now, let's move on to question D. The function f has derivatives for all orders, for all real numbers. The fourth derivative of s equals this guy. If the third degree Taylor polynomial for f about s equals 0 is used to approximate f on the interval 0, 1, what is the Lagrange error bound? Alright, so again, about s equals 0, which means c equals 0, and this guy becomes Lagrange polynomial, right? Look, the third degree Taylor polynomial, so you have R3 of s less than or equal to absolute value of maximum of, so it's going to be maximum of this one, again, c less than z less than s, right? So c equals 0, s equals 1, right? If you need maximum of this guy, and then this guy maximum when cosine equals 1, right? So then you have e to the first times s subtract c is going to be 1 subtract 0 is going to be 1 power 4 over 4 factorial, right? So you're going to print up the calculator. So you have e to the first divide by 24 and then press Ctrl Enter. It's going to be 0.11326, right? Now let's move on to example number 2. Find the third degree polynomial approximation for e to the s equals 1, center s 0, right? So this one s equals 1. This is c equals 0. Use the Taylor's inequality to find the range of possible values for e to the s equals 1, center s 0, right? So you need to find the polynomial approximation for this one first, right? This is third degree polynomial, right? So we have p sub 3 of s, right? So if you look at this one, this guy actually the second degree polynomial for e to the s, right? And then third degree polynomial, you just write s cubed over 3 factorial, right? So you have, now you need to approximate this one, so you have e to the first, right, s equals 1 right here. Approximately p sub 3 of 1, right? So it's going to be 1 plus 1 plus 1 over 2 plus 1 over 6, right? And if you simplify this one, it's going to be 8 over 3, right? Now, Since this one is the third degree polynomial, so we're going to use R sub 3 of S always less than or equal to absolute value of maximum, right? So we're going to simplify this one. It's going to be absolute value of. Now we're going to exponentiate three sides, right? So we have e to the 0, e to the z, e to the first, right? This is the maximum, right? So it could be e times s minus c, which means 1 minus 0 is going to be 1 power 4 over 4 factorials should be 24, right? So it turned out to be e over 24, right? Now we're going to use the formula right here, right? So we have now s equals e to the s and s equals 1. So it can be e to the first, right? So it can be absolute value of e minus this is p sub 3, right? This is r sub 3, right? P sub 3 is going to be h over 3 less than or equal to e over 24, right? Now remember we have absolute value of s less than or equal to a, so negative a less than or equal to s less than or equal to a, so keep this one in mind, right? So we have negative e to the 24, right? Less than or equal to e minus 8 over 3 less than or equal to e over 24, right? Now you're gonna add 8 over 3 sides, right? So you have, so if you hit the calculator, it's gonna be, and actually e is the Euler number, it's gonna be 2.71828 repeating, right? So the range right here makes sense, right? Now let's move on to example number 3. Determine the degree of the Taylor polynomial p sub n of s expanded about c equals 1 that should be used to approximate Ln of 1.2 so that the error is less than 0.001, right? So we have the function f of s equals Ln s, right? Now we're going to take the derivative of f of s, right? So f prime of s equals 1 over s, which means s power of negative 1, right? F double prime of s equals negative s power of negative 2, right? I just use the power rule. F triple prime of s equals 2 s power of negative 3, right? F for derivative of s is going to be negative 6 s power of negative 4, right? Etc. Now we need to generalize this one, so we have f n plus 1 derivative of s equals, alright? Now observe that you have, if this one, the first derivative, you have the plus sign. The second derivative, you have the negative sign. The third derivative, you have the plus sign. The fourth derivative, you have the negative sign, right? So if you see even right here, it should be negative. If you see odd derivative, it should be positive, right? So you have the negative 1 right here, right? And then we need to relate this guy with the negative side right here, right? So if you raise to the even power, it should be positive, right? If you raise to the odd power, it should be negative, right? But it's 4. And then this guy must be 3, right? This is 3, this guy must be 2. This is 2, this guy must be 1. So that you have the negative, positive, negative, right? So this is n plus 1, this guy must be n, right? That's the first thing. Now the second thing, look at this one, 4. This is it, right? So if you reduce this one by 1 unit, you get 3. And does that mean you have 3 factorial equals 6, right? This is third derivative, right? So I have reduce 1, it could be 2. So I have 2 factorial, it could be 2 right here, right? This is 2, it could be 1. So 1 factorial, it could be 1 right here, right? So this is n plus 1. So you have n factorial right here to get the coefficient, right? Now, we're going to deal with this guy right here. So this is 4 derivative, right? This is, does that mean it's going to be negative 6 over s power 4, right? So then this guy must be the same, right? So this guy right here and the bottom right here, s to the n plus 1 must be the same, right? Now we need to set up the error. So we have the error absolute value of r sub n of 1.2, right? Less than or equal to absolute value of maximum f n plus 1 derivative, right? Times s minus c raised to the n plus 1, right? Over n plus 1 factorial, right? Now c equals 1, s equals 1.2, right? So we have absolute value of maximum of this one. This will be right here, right? So we have negative 1 to the n times n factorial, right? Times s minus c, which means 1.2 minus 1 is going to be 0.2 raised to the n plus 1, right? Over s to the n plus 1. In this situation, it's going to be z, right? To the n plus 1. I forgot z right here, right? Where z between c and s, right? C equals 1, less than z, less than 1.2, right? Times n plus 1 factorial, right? Now we need this guy right here to be maximum. If this guy maximum, this guy right here must be minimum, right? So this guy minimum, look at this one, it should be 1, right? So we have absolute value of negative 1 to the n. When you take absolute value, it doesn't matter positive or negative right here, it should be positive, right? So you're going to end up with 0.2 to the n plus 1, right? Now the top right here and the bottom right here, this is n factorial, this is n plus 1 factorial. N plus 1 factorial can be written as n plus 1 times n factorial, right? So this guy cancel out, right? So the bottom should be n plus 1 only, right? Now at this time I can remove the absolute value side, right? Now the error must be less than this one, right? So I need this guy to be less than 0.001, right? Now n equals 1, substitute 1 for n over here. You get 0.02, right? N equals 2. You get 0.0027, right? This guy is still greater than 0.001. This guy is still greater than 0.001, right? Now n equals 3. You get 0.0004, which is less than 0.001, right? So n equals 3 is the final answer, right? Now let's move on to question B. What is the smallest order Taylor polynomial center f s equal 1, so which means c equal 1, right? Which will approximate e to the s minus 1, so we have f of s equals e to the s minus 1, right? On the interval 0, 3 with a Lagrange error bound less than 1, right? So first you need to have the Taylor polynomial for this one, right? So you already learned in topic 10.11. If you don't know how to do it, just visit that videos, right? And we're gonna revisit this concept in topic 10.14, right? So now I'm gonna leave this one for you to practice. I'm gonna give you the answer for the Taylor polynomial, right? You have the error bound. It's gonna be given by the formula, and you know that z is between 1 and 3, right? And in order for this guy to be maximum, z must be equal to 3, right? So substitute 3 for s into this one, right? So you have e to the 3 minus 1 is going to be e squared, right? So substitute over here. So the maximum should be e squared, right? Now s right here equals 3 and c equals 1, right? Raised to the n plus 1 over n plus 1 factorial, right? And then you're going to simplify this one. It's going to be e squared times 2 raised to the n plus 1 over n plus 1 factorial, right? We need this one to be less than 1, right? So we just sketch the table, right? So you have n right here, and this is r sub n of s, right? Now if n equals 1, you just use the calculator. You get e squared times 2 power of 2, right, over 2 factorial. So it's going to be 14.778, right? Now n equals 2. You do exactly the same thing. You get 9.852. N equals 3. You get 4.926, right? N equals 4, you get 1.970, right? And n equals 5, you get 0.6568, right? Now finally, this number right here less than 1, so you stop, right? So n equals 5. Now let's move on to example number 4. The function g has derivatives of all orders for all real numbers s. Let t sub n of s be the third degree Taylor polynomial for g about s equals 1, so you have the center 1. The maximum values of the n derivative of g for s between 1 and 1.7 for selected values of n are shown in the table right here. What is the maximum error guaranteed by the Lagrange Error Bound when t sub n of s is used to approximate g of 1.7? So this one is s, right? So you have absolute value of r, this is third degree, right? So the error r sub 3 of 1.7 less than or equal to absolute value of maximum of f. This is 3, this guy must be 4 derivative, right? In this situation, the function is g, right? So I change this one to g of z, right, times s minus c to the 4 over 4 factorial, right? Now I just substitute value, so I have absolute value of maximum of g, the 4 derivative, right, of g times s equals 1.7, c equals 1 to the 4 over 4 factorial, this could be 24, right? Now the maximum right here, g4 derivative, is could be 3.7, right? So it could be 3.7 times 0.7 to the 4 over 24, right? So we're gonna print up the calculator. It's gonna be 0.037, right? Now let's move on to example number 5. It's gonna be exactly the same thing as example number 4, right? This one is third degree Taylor polynomial about s equals 2, so this is c equals 2, right? And then g of 1.5, so s equals 1.5, right? So we have r sub 3 of 1.5 less than or equal to absolute value of maximum of g4 derivative of c times s minus c, right? S equals 1.5, c equals 2 raised to the 4, right? Over 4 factorial. So Now the maximum right here. Now remember that Z is between C and S, right? So between 1.5 and 2, right? So the maximum should be Z equals 2, right? So G for derivative of 2 is right here. It could be 3, right? So you have 3 over 24, right? Times 0.5 raised to the 4, right? So we're gonna print up the calculator. So you have 3 times 0.5 to the 4. Then press Ctrl Enter. Divide by 24. Press Ctrl Enter. It's going to be 0.078, right? Now question 6 similar to question 5, right? So we look at this one right here, we see that the 4-degree Taylor polynomial, right? Center 1, so you have C equals 1, right? S equals 0.5, right? So you have absolute value of the remainder R sub 4 of 0.5 less than or equal to maximum of H, the fifth derivative, right? Of Z times S minus C raised to the fifth over 5 factorial, right? So it's going to be maximum of this one. Get the interval right here, alright? So maximum of this guy when Z equals 1, right? So Z equals 1. So H, the fifth derivative of S should be 2, right? So you have 2 times subtract C, which means 1 to the fifth over 5 factorial. Alright, so we're going to simplify this one. So it's going to be 1 over 2 and 2 right here cancel out. You have 2 to the 4 on the bottom, right? 2 to the 4 is going to be 16, right? And 5 factorial is going to be 120, right? So it's going to be 1920. And this guy actually less than 1200, right? So this one has been proved. Now let's move on to example number 7. The Taylor series for a function f about s equals 3. So this is the center, right? Is given by this series and converges to f for 0 less than equal to s less than equal to 5. If the third degree Taylor polynomial for f about s equals 3 is used to approximate f of 13 over 4. What is the alternating series error bound? Alright, so we look at this one actually the n terms, right? So we have a sub n equals, since this one, the third degree Taylor polynomial is used, right? So then you have the 4 terms, right? The 4 terms becomes n equals 4, right? So 3 times 4 equals 12 plus 1 is going to be 13 over 2 to the 4 is going to be 16 times s right here equals 13 over 4 subtract c, right? So it's going to be 13 over 4 subtract 3 raised to the 4, right? Now the alternating series error bound, so it can be absolute value of R3 of S, right? S equals 13 over 4 less than or equal to the next term, right? So which means less than or equal to 13 over 16 times 13 over 4 minus 3 raised to the 4, and that's the answer, right? Now let's move on to example number 8. Let f be a polynomial function with non-zero coefficients such that f of s equals this guy t sub 4 of S is the 4-degree Taylor polynomial for f about S equals C, such that T sub 4 equals this guy, based on the Lagrange Error Bound. F of S subtract T sub 4 of S must be equals which of the following? Alright, absolute value of R sub 4, right? This is 4 degree of S equals absolute value of f of S right here. Subtract T sub 4 of S, right? And remember R sub 4, which means the next term, right? So the next term should be this guy right here, right? Let's move on to question B. Let f be a function that has derivatives of all orders for all real numbers, and let p sub 3 of s be the 3rd degree Taylor polynomial for f about s equals 0, right? So you have the center c equals 0, right? Now you given this formula for n between 1 and 5 for all values of s. Of the following, which is the smallest value of k for which the Lagrange Error Bound guarantees that absolute value of f of 1 subtract p sub 3 of 1 less than or equal to k. P sub 3 of s be the 3rd degree Taylor polynomial approximation, right? So we have r sub 3 of s right here is the Lagrange Error Bound, right? And this guy must be less than or equal to k right here, right? And this guy equals f for derivative, right, of c s minus c raised to the 4 over 4 factorial, right, less than or equal to k. Now we just substitute values. We need to find maximum of this guy, right? Now since this guy less than or equal to n over n plus 1, right? So if it's equal, you just substitute the value of this one for n, right? So 4 for n, so it's going to be 4 over 4 plus 1 is going to be 5 times s equals 1, and then c equals 0 raised to the 4 over 4 factorial less than or equal to k, right? So it's going to be 4 over 5 times 4 factorial, right? 1 minus 0 raised to the 4 is going to be 1, right? Less than or equal to k, or k greater than or equal to 4 over 5 times 1 over 4 factorial, right? Now let's say smallest value, which means the minimum of this one, minimum when the equality occurs, right? So minimum is k equals 4 over 5 times 1 over 4 factorial. The answer is D. Now let's move on to example number 9. Alright, let p of s be the 6th degree Taylor polynomial, right? So we're going to use r 6 of s, right? For a function f about s equals 0, so c equals 0, right? Information about the maximum of the absolute value of selected derivative of f over the interval 0 to 1.5 is given below, right? So this is 5th derivative, 6th derivative, and 7th derivative, right? Now, since you use the 6th degree Taylor polynomial to approximate, right? We need to use this guy, right? So we have r 6 of s equals, now remember z between, now maximum is 4h1.3, right? So you have 4h1.3 times s equals 1.5, c equals 0, so it will be 1.5 raised to the 7 over 7 factorial, right? So you're going to print up the calculator. You have 4h1.3 times 1.5 raised to the 7, right? Then you need to divide by 7 factorial, right? So press the button right here, hit the factorial and press Control Enter. The answer is 1.631, right? Now let's move on to example number 10. Question 8. Write the third-degree Taylor polynomial for f about s equals 2, so you have c equals 2, and use it to approximate f of 1.5, right? So we have p sub 3 of s equals, now we substitute values, right? Now f of 2 equals 6, right? So it could be 6. F prime of 2 equals negative 12, so minus 12 times s minus 2, right? Because c equals 2. F double prime of 2 equals 18, right? So plus 18. 18 divided by 2, it could be 9, right? So 9 times s minus 2 squared, right? Plus f triple prime of c, it could be negative 24, right? Divided by 6 right here, because 3 factorial equals 6, right? So it could be negative 4 times s minus 2 power 3, right? So we have f of 1.5 is approximately p sub 3 of 1.5, right? Because the question wants you to use p sub 3 to approximate this one, right? So you substitute 1.5 for s over here and you print up the calculator, right? So if you use the calculator, the answer must be around 14.751, right? Question B. The fourth derivative of f satisfies the inequality for s greater than 1. Use the Lagrange Error Bound to show that the approximation found in part A differs from f of 1.5 by no more than 1/8, right? Now, in question A, we're going to use third-degree Taylor polynomial, right? So the error should be absolute value of r sub 3 of 1.5, right? This guy less than or equal to. Now the maximum of for derivative of f is to be right here 48, right? So this guy equals 48 times negative 0.5 raised to the 4 over 4 factorial, right? We're gonna simplify, right? So it could be 48 times negative side raised to the 4 could be positive, right? So I have 1 over 2 power 4 over 24, right? 48 divided by 24 is going to be 2, right? So you have 2 over 2 to the 4, right? So it could be 1 over 2 third, right? And this guy equals 1/8, right? So finally, we just prove that this guy less than or equal to 1/8, which is right here, right? Now let's move on to the last question, question 11. The function f has derivative of all orders for all real numbers. Value of f and its first four derivative at s equals 3 given in the table. Write an equation for the line tangent to the graph of f s equals 3 and use it to approximate this one. Okay, very simple, right? So we know that the slope intercept from y minus y1 equals m times s minus s1, right? So we have y minus y1. So you have s equals 3 and then y should be 4, right? Look. So you have y minus y1, y1 is 4, right? Minus 4 equals the slope is negative 8 right here, times s minus 3, right? So you have f of 2.5 equals negative 8 times 2.5 plus 28, right? It's going to be 8, right? Now question B. Write the third degree Taylor polynomial for f about s equals 3, so c equals 3, right? So we have third degree is going to be p sub 3 of s equals. Now we're going to simplify this one. C equals 3, so you have f of 3 equal 4, right? F prime of c equals negative 8, right? So minus 8 times s minus c F double prime of C is going to be 14 right here. Plus 14. 14 divided by 2 is going to be 7. So plus 7 times S minus C, which means minus 3 squared, right? So right here I just write 3, right? Now F triple prime of C is going to be negative 22, right? So minus negative 22, and this is 6. Divide the top bottom by 2. So negative 11 over 3, right? Times S minus 3 cubed, right? Now you need to approximate F of 2.5, right? So F of 2.5 approximately P sub 3 of 2.5, right? So it's going to be, if you use the calculator, the answer is going to be around 10.208, right? Now question C. Is there enough information to determine whether F has a critical point as S equals 2.5? In order for S equals 2.5 to be a critical point, you need F prime of 2.5 equal to 0, right? So we look at this one right here. We only have F of 2.5. We don't have F prime. And we look at the table right here. We actually don't have it, right? So we're going to say no. Now question D. The four derivative of F satisfy this inequality for S greater than 2. Use the Lagrange Error Bound to show that the approximation found in part B differs from F of 2.5 by no more than 1 over 8. Now this question is similar to question 10b. I'm going to leave this one for you to practice. Now let's move on to question E. What is the coefficient of the S minus 3 cubed term in the Taylor series for F prime, the derivative of F about S equals 3? Now remember that the n degree term in a Taylor polynomial is this guy right here, right? Where this guy is the coefficient, right? So we have, now observe that this guy right here is the derivative of the function f, right? So in order to get this guy, the function f must have the s minus 3 power 4 terms, right? So when you take the derivative, you're going to use the power rule. So it could be 4 times s minus 3 power 4 minus 1 is going to be 3, right? So, and in this situation must be 4, right? So we have f for derivative of c over 4 factorial times s minus 3 raised to the 4, right? Because it's center right here, right? So I'm going to look at the table right here. F for derivative of 3 is given in this table right here, 30, right? So you have 30 over 4 factorial times s minus 3 raised to the 4, right? Now I need to take derivative of this one, right? So I have f prime equals, bring 4 to the front, so it will be 30 over 4 factorial times 4 times s minus 3 raised to the 3rd, right? Now the question asks you to find the coefficient only, so you only worry about this guy, right? So the coefficient is going to be 30 times 4 over 24, right? Now 4 and 24 cancel out, so 30 over 6 is going to be 5. That is the final answer. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher.